Hey, how's everybody doing?
Good.
Kind of interesting walking back into this building, because the first time I walked into this building was 20 years ago, and it was a crazy party. And out front was a beautiful miniature, but basically huge, capsule from the Apollo 13 movie. And this building was being operated at the time by Digital Domain, which I worked at for a number of years. And one of the reasons that I started moving towards cloud was the kinds of things that you see happening in post-production for 10, 15 years at least, if not longer, which is that these businesses doing production for Hollywood are all putting a huge amount of risk up front to accomplish the goals of telling a story. And it's really poorly placed investment to buy a whole bunch of equipment, to own these things that in every other aspect of production has always been rental, has always been something that you do as a budget of a production and not as something you keep. But the only way to get that kind of technological innovation was, at the time, to invest in it. You had to have people that could work on extremely high-end technology, cost millions of dollars for the computers. And we built a mindset and a momentum in our technology that was about owning our own data centers. And you see that now with studios, you see it now with post-production companies. You see a lot of Hollywood owning a lot of technology. But I think we're moving back away from that model. I mean, it's pretty obvious that we're moving towards a cloud model. So in 2006, 2007, I started working on moving a lot of the infrastructure I was designing for pipeline for our types of production work, on-set and virtual production, and some of the things that I was involved with general, storytelling and modern visualization and CG technology, and moving it into the cloud, so I didn't have to buy that equipment anymore, right? It's the perfect model. So the thing that I hear people say sometimes that's kind of, I think, a little frustrating is that the cloud is somebody else's computer. But do we say that the camera we're using on set is somebody else's camera? Hollywood is actually, almost uniquely, already akin to this model. It's completely familiar to us, right? We know how to get the talent, that's one concern, and get the equipment that the talent needs to execute their talent separately, right? We just went off on a detour for a while because the only way you could do any of the high-end post-production work was to have that kind of huge investment. So as we started trying to move into the cloud, I started realizing that it was hard. It was really, really hard. And the main reason it was hard wasn't because any of the technology in itself was hard. In fact, the technology compared to like writing renderers or render queues or virtual production or anything like that, that was all comparatively simple. But it didn't coordinate well together. We're using what's basically web technologies to try and do film production. And the priorities are all backwards, because when you're dealing with web, you can always talk to the server, right? You always go out, get the server's fresh information every single time, because the data that you're working with is relatively small. It's a web page, a few JPEG images, things like that. It's not, a single shot that takes, 50 gigs. Plus, maybe even more than that, because of all the elements and layers and all the other pieces that have to be available to, say, do a composite. So, well, I shouldn't have gone so fast. So, what the main problem to solve ended up being was how to make the entire problem domain of coordinating things in the cloud for production simpler. Everything that we're seeing in that space starts out, or in any space, really starts out as very complicated, because that's the easier thing to do first, because it's just like, however it falls off the truck, this is a good idea, let's do this. It's kind of almost, especially for creative types, almost an appealing idea to put more into it. But I'm trying to live by this quote, which is that if I had more time, I would have written a shorter letter, right? It's like the smaller, the tighter, the better, the faster, the simpler, the easier to understand things are, the harder they are to do. Look at Tabasco sauce, only 3 ingredients in Tabasco sauce. Look at sushi or sashimi, there's only 1 ingredient in sashimi, right? And yet we consider it to a large degree to be at the very top of the scale in terms of art in food. The same thing applies to technology for doing this kinds of coordinating work. So we worked very hard for years and a lot of incorrect directions along the way to finally kind of come down to a framework to explain and to drive and to interconnect all of the tools that we need to use for production. So as a physical example of that, just you don't have to know this or read any of this. It's just an example of what we have today. Probably there's something even better today because YAML's been around for a bit. But on the right, you have a YAML format file. On the left is an XML file. These are basically the XML files you would get off of an Aspera from a shot. Some parts of it clipped out. It's the same amount of data. It's exactly the same data, in fact, on the left and the right. People always say, oh, it's XML, it's human readable. I don't consider XML human readable. It is ASCII, or it is a text format so that you could sit there and read the words that are in it, but that does not mean it's human readable. So on the right, you have something that may be still not quite human readable unless you know what you're talking about, what the terminologies are, what the values mean, but still, at least you're not having to visually remove the cruft of closed tags, open tags, closed tags, angle brackets, all these other things that are not actually strictly even necessary to represent the data. So over time, we've gotten, just in a text representation, better at representing text in a more useful way, in a smaller format. So this is what you might expect to see in a typical production, with or without the cloud. I've kind of indicated the cloud and the thing in the top, but Hollywood kind of has always had this model of having to interact with a lot of different business units, an editorial house, a visual effects house, on set, a transcode or lab when it was filmed, right? So we have this modularized business model already. Cloud is not a huge step away from that. It's basically the same idea. It's just an opportunity to do some automation. And so when we started looking at the cloud, we really had to have a better definition of what the cloud is. And even today, almost 10 years on, people are still kind of ambiguous about the cloud. You can have your own definition, but this is the definition I use. First of all, I don't believe in private cloud or public cloud. There is the cloud. I do believe in the cloud. A lot of people say, well, there isn't, cloud's just the internet, or cloud's just somebody else's computer. But no, the term for the cloud actually has value, it has some meaning. And so we define it like this. It's about these 3 main ideas. Collaboration, worldwide collaboration, being able to interact with people, with your data. Everybody has full access to a larger and larger scale, and now we're having to consider the entire world. Consumers have this level with things like Dropbox and Google Drive and so forth. Then the other piece is scalable storage, so that you can scale up, store all your data that you need to do your production, and then remove it, scale back down again, and you're not paying for that infrastructure. So scalable storage, right? That's something that we didn't have before. That's what differentiates it from just computers on the network. That's what differentiates it from your own data center that you can't scale. It doesn't scale. You can buy more, but that's not exactly scaling because you're going to be on the hook for it when the job goes away still. And then the same thing for compute. You can scale up the computational power. So the cloud has these values that are distinguished from your own data center and distinguished from just general computers on the internet. So all this complexity and how to try and interact with all these things, all the problems that are coming about because of trying to adopt the cloud, trying to take advantage of these benefits of the cloud for production, we've gone over it and over and over and over it again, and it really comes down to just two questions with respect to how we're communicating about data. The first question is, do you have this file? I mean, if you work in production, you probably either ask some version of this question all the time, right? You're asking if you have it, if they have it, where is it, right? You want to know information. You know what file you're talking about, sort of, but you don't know where it is, or you do know where it is and you need to talk about it in some way. And the other question is, what do you know about this file? In other words, I have something. Do you have any more information about it? Right? Here's a shot. Do you know what the production day was? Do you know who the actor is in the shot? Right? Information about it. We call it, assets or essence and metadata. I think that's starting to get a little bit unnecessarily technical because really we're just talking about these two questions. We're talking about like, I have a thing, I want to know more about the thing, or I don't have a thing, but I want to be able to find it, right? I have a production name, I have a production schedule, I have some tags, I know what date that shot was on, I know it was a circle take by the director, I want to be able to search for it. Database kinds of operations, right? We're doing most of that, both of these questions today, by just human interaction. Everybody just asks each other these questions. That's what a production does. So here's some examples of what these questions might look like, and the reason why they aren't clearly two separate questions most of the time. It's hard to say which question these ways of asking it are. You could have a person in an email saying, hey, do you have this file named clip.move? Or you could say, a database SQL query, select everything that's in this database that's named this thing. Or you can look in a specific path, like a naming convention or so forth. All of these have one obvious problem, which is they require a priori knowledge, right? I have to know the name of the file in two cases. I have to know SQL in another. And I may have to know a file path or a naming convention or something like that. So I put all of this information, the clip.move, the a6-4_0050.move, which who knows what that means, and all those directories in that path, I consider those all just metadata. Because they're not the file itself. We're just talking about things that are associated with the file. So let's say this is the file. This is a clip from the Suitcase project we're working on with our ETC is working on, and I'm helping with the C4 side of it to test this in various aspects and to standardize the usage. So this has tags at the bottom of it, it has time code, it has information about it. I might be looking at this thing, but what little information I might have just looking at this shot, how much further can I get down the road? And today, the answer is not very. So naming conventions have this a priori problem where if you know the structure, then maybe you can use the data that's in that structure. But really, that means that you have to know basically what it is that you would actually want to search for. You might say, well, I know what the shot is, but I would love to know, like, if it's in a rigging or in a, animation or in a, has shaders attached to it. I might want to use things that we're using as file paths. Those might be handy tags for me that I don't know, right? I know that I have the shot. I want to know what other tags does it have associated with it. Does somebody have some other point of view of the shot that's useful to me? Or I might have a naming convention like the ARRI one, which to an expert has some meaning to it, but for the most part isn't very human readable either, and that's just regular file names and file paths. It's good for organization, for mechanically, but it's hard for humans to interact with. So C4 defines several different areas. For the last year, I've been doing a lot of technical talks about how the C4 ID system works. I'm going to show some real examples today, in addition to talking about this kind of philosophical approach to the whole thing. So this kind of sums up the problem with identification. So everything I've said so far, and then here's the physical manifestation of these problems, which is every other ID system is an assigned ID. If I attach a name to a file, I'm assigning that thing. I could just as easily change the name, right? There's nothing prohibiting me from doing that. So I could have exactly the same file in two different file paths, right? And maybe that loses some of the meaning, or maybe I just can't find it because I don't know what that file path is. There's an ID system like UMID or UUIDs, but they're effectively random. They're just a unique ID, but they don't but they're almost too unique. If you had a unique ID that was generated in one location, one company, and a UMID generated at another company, then for the same exact file, there might be different UMIDs. So if we want to coordinate, this is where the complexity starts to come in. If we want to coordinate between those two organizations, they have to have a centralized repository of knowledge, right? We've named this file this UMID. You also should name it this UMID, or at least understand when you find this file that this is the UMID that it has. So we have to communicate through that central repository, that central knowledge. We have this shared communication between each other. Problem with the cloud is, and really production in general is, you don't know who you're going to be dealing with next month. You don't already have in place that communication all the time. In fact, you rarely do unless you're news or broadcast where you have a very, very regular production schedule and organization and interactions. The C4 ID, on the other hand, is always the same for the same file. We never have to communicate about that ahead of time. We'll always have the same ID if I talk to somebody tomorrow that I've never talked to before and ask them, hey, download C4, run it on this file, tell me what the number is. If it's the same file, it get the same file number as I have. And if it doesn't, I know that it's a different file. So now we don't have to communicate. We don't have to plan in advance and coordinate with any kind of central registry where all the files are and what identification we've assigned to it, right? And that's a huge separation. So that goes back to the two basic questions. Do I have this file? Do you have this file? Now we can say absolutely, unequivocally, yes or no to that question, right? I can search through an entire file system, get the C4 IDs on the files. If I don't have the one that I'm looking for, I don't have the file. If I do have one or more that have the same ID, I do have the file. Doesn't matter what it's named, doesn't matter when it was created in my file system, doesn't matter where it came from. So now I can sync up with other organizations based on that fundamental building block of we can unequivocally identify this file. And we agree without communication on what its ID is. So now we take it one step further. We can take that ID, that absolutely unique, immutable ID that we would agree on without communicating is the ID of a particular file. We can stuff that into things like XML or JSON or databases or whatever. And now it creates what I call indelible metadata. This idea that once I've computed the C4 ID and associated it with other data, my entire system could collapse, my DAM could go, my database could go, but if I have that text file that has that ID and that metadata with it, and I have the file that generates that ID, then I can relink, I can rediscover that structure again. Don't have to have any infrastructure to do that. Well, you probably have to have a file system and a hard drive or something. So what that might look like in practice, if any of you are familiar with command line tools, is you might be able to list a directory. Here's a couple of files. You could get a C4 ID off of those files. And then you could just grep through all of the data in your file system for that ID. See if you have any other knowledge in your entire organization about those two files. So this is what that would actually look like in practice. I'm saying, OK, well, I have this clip, the clip we just watched a minute ago. It's called Clip Movie. I need to find something about it, and I don't know anything at all about it. It's not even named usefully. So I get the ID of it. Then I'm going to go up to the suitcase. I'm going to search the entire suitcase project for that C4 ID, see if there's any other files that have the same ID. Nope, just the one I was looking at. OK, well, are there any other text files that I could grep that might have that ID in it? So it searches through all the files, and it finds, oh, look, there's a notes file that has that C4 ID in it. And it's just a text file. It's not a special file. It's not a database file. It's not binary. Nothing magical about it. It's just that at some point, I made some notes about, hey, I created a trimmed clip from this source file, which I have the file name for. But better yet, I have the C4 ID of the source file. So now I can search for this C4 ID. I can run C4 IDs against my file system and find that source file ID. So now, when I do it here, deliverables Pyx A6-4, I found the actual file, right? So I was able to discover this without any structure at all. I don't have a database. I don't have anything except for notes in a text file somewhere. So this creates this kind of self-discovering structure. You can optimize it. You can use it with databases. It's regular ASCII characters, doesn't have dashes or underscores. You can put it as a database field. So you can use databases. You can use all the normal tools you might use with file names or anything else to optimize your process to make things faster. But it is very stable even if those tools aren't in place. Those tools just kind of make the whole process of it connecting your data more stable, more reliable, harder for some piece that might break somewhere along the way to interfere with your workflows. So with C4 as a framework that ETC is working on, this means that if everyone starts using C4 IDs, in this case, I take that same ID, I go to Pyx, and I search for Pyx with that same ID. And Pyx now is using C4 IDs on their systems, so they find the C4 ID. They have, when I search, I find the C4 ID of the file in Pyx. So now you can imagine organizations or software tools, cloud providers or different companies working on a production can, if they have C4 IDs, they have some interface, a web interface or a database that you can have an API to or whatever, they all can interconnect because now you're all basically talking more or less the same language. You can at least do authoritative generic searches against the ID of a file. And then vice versa, the other part of the other question, what do you know about this file? So this is, I asked Pyx, what do you know about this file, this C4 ID? And it gave me what it knows about it. It gave me the actual clip. A different service might say, oh, well, I did a whole bunch of transcodes, and this is what it ends up being. Or I copied it to India, or whatever the information might be that is available for it. So this creates this interoperability, but it also creates this dependency graph where we can describe now, authoritatively, workflows in production. And any step of these could be a software tool, a human process, a cloud provider. It all can be in this kind of unified address space where we're all talking about the same thing. So I can have raw files leading into clips, leading into an editorial's EDL, which gets conformed, transcoded out to a whole bunch of delivery formats. And I can express that really easy in a database, in an XML, in this case a YAML file that says the conform. This is basically what the domain language of C4 looks like, which is the deeper you go as you nest in, just return tab, The deeper you tab in, the more of a dependency it is, right? So conform depends on an EDL in the media. But I don't even have to really tell you where the media is. If you have it, you'll find it, because there's the C4 IDs for it. And there's no question as to which edit it is. It's the edit that has the C4 ID, right? Might be the airplane edit, it might be the TV edit, might be the theatrical release. But I don't have to have it named anything in particular. That is authoritatively the one that you should use for this particular conform. Software tools can absolutely rely on it, and human beings can also. It's not particularly human readable, but it's human useful. So you can take that, search for it, find out what name you're calling it in your file system, and then relate that back into the terminology that you want to use. So some people ask, why aren't we using, this is basically a hash, why aren't we using something like MD5? We use that all the time. Aside from the fact that MD5 isn't big enough for a global ID system, it doesn't have a standard representation. So all of these are exactly the same MD5. So that presents a problem, because I don't know if you're going to use the same MD5 in the same format, so now I have to consider, oh, well, is it hex? Is it base64? Is it just an array with the numbers in it? Like, I don't know how you've done it, so I've got to check all of those, right, to see. And even then, it doesn't work globally, just too small of a number space. C4 IDs have these properties. They always start with C4. They're always 90 characters long. They have no underscores, no dashes, no slashes. If you find it, as you saw when I was interacting with it in the command line a second ago, if you double-click it, it'll select the entire thing. It won't select up to a dash or something. So as a human being, even though there's no readable element of it, if you run across a C4 ID in the wild, you'll know it. You'll know because it's that big and it's got a C4 at the beginning. So it's just slightly better ergonomics in terms of being able to double-click it, throw it into an email, talk to somebody about it. It eliminates a few confusing characters. As you can see, they're even confusing in the slide. That's actually a 1 and a lowercase l, I think. And then a / and a backslash and a colon. So these characters are removed because they're either interpreted as white space and so stop a select, or they're just confusing. And so if you were to read it over the phone to somebody, you might make a mistake on certain fonts with those characters. So the typical characters will be pretty easy to identify. So we're using this system to kind of create a very simple but very stable base environment for this framework that then we can have interoperability between cloud providers, between software providers, and human beings, so that there's not this need to track every single movement of a file. You don't have to know, oh, I had that file in this path, and now the database needs to be updated because I've moved it over to this other path. Or now it's on the tape, not on the hard drive anymore. Or now it's, So this can be used in a lot of other areas that help kind of pay for this incremental steps towards using C4 as your standard identification system. If you can use it for data deduplication, so you can run this on your file system. All the IDs that are the same file. You can decide to get rid of the copies you don't need. You can check a destination folder and a source folder and see how different they are authoritatively, regardless of their names. There's a technique called Merkle trees, which allows you to take a single, when you do C4 IDs, it's not just for a file, it could be for a folder as well. It's still only a single ID. You could have, in fact, a file system storage that goes up to the root level file system and have a single ID at the root for petabytes worth of storage. And that ID represents everything as it exists in that file system. So you could use that to synchronize two very large remote databases or file systems. S3, for example, in Google Storage, you could identify all these things in their own space without moving any of them, without having to transmit any of this data across the wire to compare, do diffs against. And if the top level ID is different, you can just go one directory system down, Or in the Merkle tree example, it's a binary tree. So you go down one, it's 2 IDs. And then it says, oh, only the left one's changed. OK, then you go down that one, but you ignore the other one, which means you've just ignored half of the data that didn't change, right? You can do that all the way down to a single file. You may go 6 or 7 steps down a Merkle tree and identify the exact and only file that's changed and do the update. So it can be used, and Merkle trees are used in network communications all the time, so it's a very efficient way to provide that level of synchronization. So this is all open source software. You can get it at ccc.io. The command line tool is there now, and shortly there will be a GUI tool so you can drag and drop folders and files and stuff into it and get the IDs of them, cut and paste them and throw them in emails or use them in your databases or whatever. Source code in Python and Go and C. We're getting more and more languages supported so that you can either link it into your own tools or just use these command line tools directly and so forth. So that's an overview of what we're doing.
This is going to get some questions here.
It's simple. It's supposed to be totally self-explanatory.
So why 90 characters?
So the C4 ID is based on SHA-512, which would be 64 bytes if it were full bytes. But since we're using this base 58 character set to encode it to, it turns out that the maximum number that you could possibly get, maximum number of characters that you would possibly get if you tacked the C4 on the front would be 90. So we pad anything that's less than that so that it's always 90. We just add leading zeros, which in this case, since we don't have 0, we add leading 1s. So that's 0 for C4 speak.
Cool. Any other questions right offhand? Oh, I see. Yeah.
Okay, this is from the end user who has infinite incorrectly named files.
Yeah.
How does this get applied to the files? I don't understand
So
how it becomes attached.
every file that has ever existed and every file that ever will exist already has a C4 ID. All anyone ever has to do is run the tool and discover what it is. Right? So it is not attached in any particular way. It's a property of the data itself. And it doesn't even have to be a file. You could just pick some arbitrary block of data and not create a C4 ID off of that. In fact, there's a C4 ID that's 90 characters long for an empty file. So that ID, you might, for example, put that ID in a database and say, here's this ID, and it's also found in these paths. Here's 20 different paths that this exact same file is found at, right? Because you might have lots of paths to a copy of that file. So that's how you might, like, if you have lots of disorganized files, you could use a system like that to say, oh, well, those two are the same, and I named it differently, or this is version 1, and this is just something else. I mean, those are the kinds of the use cases for this also, is being able to do authoritative version control and, like I said, indelible metadata and so forth.
It's also great for data deduplication. So you can go and figure out that you have 20, 30% of all your files that are the same. And we're really working to get it all over the place. Again, it's an open source tool. We've got it now on the Technicolor carts. We have it, I believe, also on the PhotoChem cart.
Actually, I meant to ask that question at the beginning. Has anybody here before today heard about C4?
Yeah.
Oh, that's more than half. That's fantastic.
Great.
So yeah, it's getting a lot of take-up quickly. Lots of tools are starting to adopt it. You'll see more and more things that just, like Pyxis I showed, that just has it built in.
Yeah.
So you can just use it immediately. You'll have immediate benefit in being able to interoperate with different tools day one.
Cool.
All right, thank you.
Thank you so much, Josh.